Hey project professionals, welcome back to my channel. If you have ever launched a product only to hear the customers say, that's not what I asked for, you know the pain of the poor quality. Today, we are tackling the PMP Quality Management, the essential knowledge you need to ensure your project is successful and accepted. So let's dive right into it. Today, we are tackling, now you already know that now this is from PMP 6th. However, it's still very, very important for you to know the concepts of all of the knowledge areas and process groups. So today, as I mentioned, we'll be covering the quality management and all about it. So although it just seems very brief, it's a very short section, but very, very important for any of the projects. Quality is the core. So let's dive into it and let's see what all things quality management involves. First is, of course, we make the quality management plan. By now, you already know what is any management plan includes the how we are going to plan the quality. Next is perform quality and control quality. We are going to learn about how to perform, control, and manage the quality throughout the project. So let's see what are the core concepts of quality and what's the difference between the quality and the grade. This is from PMP 6th. However, it's still very, very important for you to know. Let's start with the fundamental definition. Quality is the totality of the entity, the degree to which the project's features fulfill requirements. If the product is unacceptable, the project is not finished yet. So what is quality and grade? Now, quality and grade goes hand in hand, but they are different. Grade is the ranking or category. For example, we need wood for our project. Let's start with the fundamental definition. Grade decision is whether we use expensive oak or basic forest wood. Both are wood, but the grade is different. So you see the difference. What is the nuance of the grade and quality? Grade is the ranking of or any of the categories, while quality is quality of any of the product. For grade, low quality is always a problem. Low grade is not a problem if it meets the requirements we agreed to. Okay, so low quality is always a problem. For example, grade decision is whether we use expensive oak or basic phone and Nokia phone. Now you might say Samsung phone is better in quality. However, in this scenario, let's take an example of this, that Samsung phone, if you have a Samsung phone and the quality and your battery always drops maybe in 5 or 10 hours. However, if you use the Nokia phone, let's say it lasts for 2 days, the battery lasts for 2 days, phone and Nokia phone. Now here, the quality of Nokia phone is better than Samsung phone, although the grade is not always good. Now here, let's say Nokia phone is a decade-old phone and Samsung has just launched this product, but it might not be a good grade, right? So that's the difference between quality and grade. The quality management process. Let's look at the quality management process. We manage quality using an alternative approach that follows the PMI theme: plan, implement, measure, react, and document. This breaks down into 3 core categories: plan quality management, manage quality, and control quality. Now, plan quality management is the what, defining the standards and matrix. Manage quality is QA. It is the how, ensuring the processes are correct. It's kind of a prevention. Now, control quality, QC. What we call is as QC, it is the checkpoint, inspecting the deliverables for defects. In other words, inspection. Manage quality, QA is prevention, and QC, control quality, is inspection driven. This point is very important. Note it down if you guys are noting it down. To plan quality, you have to define the rules of the game. Let's say Nokia phone is a decade-old phone and Samsung has just launched this. Quality planning starts with input. We draw quality requirements directly from our requirements document. If you guys remember from our procurement video, the statement of work and the key inputs like the risk register and stakeholder register. Defining quality requirements, completion versus definition of done. What is the difference between the two? One is predictive, another one is agile. Completion criteria, that is predictive. These are the specific conditions, exit criteria, that must be met for a deliverable to be accepted in a traditional project. For example, the work is done but not yet accepted by the customers. Hence, it is not yet met the requirements and it is not considered as complete. Definition of done, on the other hand, is agile. In agile, this is the consistent single checklist for the entire team that includes the acceptance criteria. We will dive into definition of done in other videos, so stay tuned for it. If you guys remember from our procurement video, the statement of work. Okay, now let's look at quality planning and design tools. We have design for X, also known as DFX, benchmarking, design for experiment. Note it down if you're noting it down, design for X. That is important. It might come in your exam directly or indirectly. So what is design for X? X stands for nothing but excellence, like design for cost or design for reliability. These principles guide the design phase to optimize for that specific area. So X is nothing but excellence. Is excellence in the design for cost or reliability or any other area of the project. Benchmarking. Okay, now let's look at quality planning and design tools. Okay, benchmarking. We use this to evaluate the difference between the projects, compare our principles against others, including internal competition, and take corrective actions for our current project. It helps us avoid creating false goals. Now, what is design for experiment? A statistical method to examine variables to determine the best outcome, defining the optimal combination of factors where the best results wins. So design of experiment is nothing but optimal combination of factors where the best result wins. Now let's talk about the money. Quality is not free, but bad quality costs a lot more, as we all know. So let's look at the cost of quality. What is cost of quality? Now, this is a crucial thing for your exam. We divide the cost of quality into two categories. One is cost of conformance, and another one is cost for non-conformance. So, what is cost for conformance? As you can see, it is further divided into two: prevention cost and appraisal cost. So, cost of conformance is nothing but this is the good money you spend to prevent the defects before it happens. One of the things is prevention cost, that is doing by QA, money spent on team development, following processes and trainings. This includes the process review because QA looks at the process. In any of your companies or industries, you will have somebody who's looking into QA because it is very, very important. It saves a lot of cost to the company as it prevents the defects to happen and cost money. So it's better to invest in hiring a QA person rather than having the defects and finding it later on in your project, which would cost you way more higher. So prevention cost is nothing but money spent on team development, following the processes and training the team. Another one is appraisal cost, QC, which is money spent on controlling. For example, inspecting, auditing, and testing the work. So these two terms are very important for your exam. Note it down. It might appear in your exam. Cost of non-conformance. What is it? We call this the cost of poor quality. Now let's say the defects has already passed over Q and QC. We have already given it to the customer, and now you find there is a defect. And you couldn't find that defect during QA and QC. That is called escaped defects. A new term for you all, write it down. Very, very important for your exam. Now, what is internal failure cost and external failure cost? Internal failure cost is defects found before the customer sees them. That is the rework, the scrap, the rough work you do, the technical tests, all of that. What you clean it up, right? After the QA is done, you find the defect, but it is done right before, it is corrected right before the customer sees it or is handed over to the customer. So it is internal failure cost. Now, external failure cost. Defects found after the customer receives the product. For example, warranty. Some of the companies gives warranty. They claim warranties and guarantees. So if some we for example, if I buy 10,000 washing machines for my business and the vendor gives me warranty, what if the machines are defected? I return them back. Since it's in within my warranty and guarantee period, I return them back. And that's something where what is called external failure, because I'm not internal to their team or organization or company. I am an external stakeholder, right? So that is an external failure cost. Loss of reputation is another one because of the failure or poor quality. So the PMP takeaway is simple. You must spend money on conformance because it is exponentially cheaper than the cost of non-conformance. The next is execution, where we shift from planning to proactively managing the quality. So let's see what's the difference between managing the quality and controlling the quality. Managed quality is the QA process. QA is prevention driven. Remember, I just mentioned it in this video. Quality assurance, that is QA, is prevention driven. It focuses on the process by performing audits to ensure we are doing the work correctly. Benchmarking. We use this to evaluate the difference between the projects, compare our principles against others, including internal competition, and take corrective actions for our current project. It helps us avoid creating false goals. Now, what is design for experiment? A statistical method to examine variables to determine the best outcome. Tools to manage the quality. What are the tools to manage the quality? So there are a few tools. Just to name a few: process analysis, root cause analysis, trend analysis, and alternative analysis. What is process analysis? Process analysis is analytical precision, examining the process steps to find non-value added activities and identify areas for improvement. It is nothing but you identify areas of improvement for your process to make it more effective and better. Now, root cause analysis is why is the defect happening? You go to the root cause. We use the tools like cause and effect diagram, also known as fishbone diagram. It is known as fishbone diagram because it looks like a fishbone diagram where one side you write the cause and the other side you write the effect. So cause and effect is also known as fishbone diagram. It is used for root cause analysis to find the root cause of the tools to manage the quality. What are the tools to manage the quality? That is the fundamental problem of the issue. Now, trend analysis. Analyzing the past performance data to predict the future performance, as the name suggests. If we see a trend going up, it shows a growing problem we must react to. And if it is going down, we are good to go. We are doing the right thing. Lastly, alternative analysis and document analysis are also heavily used here to evaluate the potential solution and check current documentation for accuracy. Now, continuous improvement. This proactive management fuels the organization-wide quality. That is the fundamental problem of the issue. Now, trend. Other two terms which you would like to note it down is total quality management, TQM, and Kaizen. So TQM, total quality management. This is an organizational-wide continuous improvement effort. Right? Each of the streams in the organization uses continuous improvement efforts, total quality management, to improve their overall organization and the company as a whole. Now, Kaizen. This is a team-based continuous improvement. Small incremental changes made daily by working with the team. Right? These two terms are very important. Please note it down. Other two terms which you would like to note it down is we have prevented what we can. Now we must control quality, the final inspection of the product itself. Now control quality, that is QC, and statistical inspection. Control quality is the inspection of the product and defects. It is done throughout the project. Note, control quality is the inspection of products and defects. It is done throughout the project, while validation is done after the project or the phase is complete. All right. Now, what is statistical sampling? We use statistical sampling to reduce the cost of QC. We do it in a different ways. We do random sampling, stratified sampling, another few samplings. Random sampling is nothing but taking a percentage of results randomly, and stratified control quality is the inspection of the product, and sampling is dividing the total population into distinct groups. That is strata, for example, by suppliers, customers, vendors, etc., and taking samples from each group to ensure full representation. Distinct. Now, a few different sampling types: attribute sample and variable sampling. Attribute samples is defect. You say, is there a defect or there's no defect? Yes or no. It's a binary measurement. While variable sampling is how good is the product or the service, right? A measurement, how far from the quality limit is the product, is the sample. So here are the 7 basic quality diagrams which we usually use. These are your visual QC reports. That is checklist, check sheet, Pareto diagram, run chart, and so on. So just to emphasize on the important ones, let's look at it one by one, what all things and what's the difference between all of these. So checklist. Checklist is a tally sheet to ensure that the work is done the same way every time, ensuring steps are followed. Whereas check sheet is continuing motion, used to record the frequency of specific problems, defects, or occurrence. How many times did each defect occur? Right? I hope the difference is very clear. Pareto diagram. Now, a few different sampling types: attribute sample and variable sampling. A Pareto diagram is a histogram. This is a histogram that uses a weighted average and a Pareto information to illustrate the frequency of problems, demonstrating that a small number of cause for a majority of the effects. And finally, the run chart. It shows data points plotted over time. It visualizes, displays, trends, and variations. Google all of these, especially the Pareto diagram and the run chart. It is very important for you to visualize what is the run chart. It is the data point plotted over time. And Pareto diagram, one of the diagrams under Pareto diagram is tornado. We have discussed it in one of our previous videos. Go check that out to understand what is tornado diagram. And so there you have it. Quality management is continuous cycle. You plan the standards, you use management quality to prevent defects, you use control quality to inspect, and you ensure those completion criteria are met. Because remember, if the product is unacceptable, the project is not finished. Information to illustrate the frequency of problems, demonstrating that a small number of cause. Hit that like button if this breakdown helped you solidify your quality management knowledge. Next time, we'll dive into risk management. See you then. Bye-bye. Hit that like button.